Hi, today for the last day of EOC review, we're going to solve quadratic equations. So this was the most recent thing that we did, so hopefully it is not shocking. So go ahead and find your cheat sheet. Okay, so we solved by factoring, and we simplified radicals. We did the square root method, we completed the square, and then we did the quadratic formula. So that's what we're going to focus on for today. Okay, so first, solving by factoring. Okay, so first the equation must be in the form of ax squared plus bx plus c equals 0. So for it has to equal 0. Okay, so this one equals 0, so we're good to go. Okay, the second step would be to factor. Okay, so we're going to do 1 times negative 10. Okay, so what multiplies to negative 10? What multiplies to negative 10 and adds to 3? Well, that would be 5 and negative 2. Okay, and this has a value of 1, so we can go ahead and just write our factors. A plus 5 and x minus 2 equals 0. And then we set each factor equal to 0. Okay, and then we solve both of these, so we would subtract 5. And we would add 2. We would solve each equation for x, and our two solutions would be negative 5 and 2. And all this means is if we were to graph this, they would cross the x-axis. These are our zeros at negative 5 and 2. All right, the next thing we did is we simplified square roots. So like the square root of 24. So in our brains, we had to come up with the largest perfect square, if I could spell, to factor out of the radicand. So our perfect squares, so 24, I know 24 divided by 4 is a number. Let's try 24 divided by 9. No, 24 divided by 16. Nope, so it looks like it is going to be the square root of 4 and the square root of 6. Okay, then we rewrite the radicals using perfect square factors. Okay, so it's the same thing as square root of 4 times the square root of 6, and then we take the square roots of any of our perfect squares. Okay, so we know the square root of 4 is 2, and we know the square root of 6, we have no idea. So simplified, this would be 2 square root of 6. Okay, then we did the square root method. So we had a square root method when we had a square and we could just undo that square. So we take the square root of both sides of the equation to isolate our variable. Okay, so since we have a square and nothing else, we can just square root it. Okay, and that gets rid of the square, and we're left with x plus 5. The square root of 144 is 12. We have a positive answer and a negative answer. Okay, so then we would have to subtract 5. Okay, so our answer would be a positive 12 minus 5, which is 7. And then a negative 12 minus 5, which would be a negative 17. So again, these cross, if I were to graph this equation into Desmos, they would cross at 7 and negative 17. Right? The next one we did was completing the square. Okay? Because this one we can't really factor and it doesn't look like this to take the square root. So first we isolate the variable terms, which means we just kind of get this by itself. So we're going to move the 4 over by adding 4. Okay, then we have x squared plus 6x, going to leave a little space, 0 plus 4 is 4. Okay, then what we have to do is we have to add a c value, okay, to create a perfect square trinomial. Okay, so what you could do is you could cut 6 in half and get 3, and then square it and get 9. Okay, so, but we have to add 9 to both sides. Okay, and then we would factor the trinomial. Okay, so we would have x squared plus 6x plus 9 equaling 13. Okay, and then we would just factor this thing. What multiplies to 9 and adds to 6? Well, 3 and 3, which is how we figured that part out. So we would be left with x plus 3, quantity squared, because it's 3 and 3, equaling 13. And then we would solve using the square root method. Okay, so then we would take the square root, so that would get rid of the square, x plus 3. The square root of 13, I don't know the square root of 13, and 13 is a prime number, so we will just leave it as a plus or a minus square root of 13. And then to solve it, we would have to subtract 3. So this would be our two answers, a positive square root of 13 minus 3 and a negative square root of 3 minus 3. Okay, and then finally we learned the quadratic formula. Okay, so the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so to use the quadratic formula, it must be in standard form. Okay, which also means, or it could just mean like it has to equal 0. Okay, then I like to make sure we know what the a, the b, and the c value are, and then we just sub those values in. Okay, and then we just simplify. It's a lot of math, it's a lot of simplifying, and then we get down to 2 problems. Okay, split the expressions into 2 equations because we have a plus or a minus, and solve for x. Okay, so we have all these methods, and some of them work all the time, some of them work sometimes. Okay, so factoring only works sometimes, and that's just basically when we can factor it. When it multiplies to AC and adds to the B value. Okay, the square root method sometimes works. Okay, it already has to be a perfect square. Okay, it already has to have a perfect square ready to go. Okay, we could also take the square root if we had something like x squared equaling, I don't know, 100. Okay, because again, it's already kind of in that perfect square. Okay, completing the square works a lot of the time, but not always. And we kind of did that when we learned like when the B number is even, it's very easy to figure out like what the number is, but if the B value is odd, it's very hard, okay? Or if we have an A value bigger than 1, we don't complete the square until you get older to do it that way. So these are just sometimes they work, but the quadratic formula always works. It does not matter what kind of problem you have. You can have big numbers, small numbers, anything like that. Okay, just take your time. All right, so today we're just going to practice that using all of these different methods.